grandfather was not an entrepreneur. My grandfather was an inventor. When he wanted to take his idea and go to market, he had to patent it. He had to license the patent to another company, and then the other company would then make the product because they had a factory, because they had distribution, because they had the capital necessary to harness the tools of production. And so my grandfather lost control of his inventions, and he was limited by where they could go and what they could do. And in some sense, he never realized his true potential because the system was set up so that you could not be an entrepreneur in manufacturing. Only big companies could manufacture. Little guys could be inventors, but only big guys could be manufacturers. There's a movie that came out a few years ago called Flash of Genius, and here's a picture from it. This is about a similar invention. This is about the intermittent windshield wiper, and that's the little delay in the windshield wipers when it's not raining very hard. In this movie, exact same scene. An inventor in his garage or his workshop comes up with this idea, and it comes up and has the tools necessary to make this prototype. And just like my grandfather, it works. It's inspiring. He patents it. But then he made a mistake. This is 1960. His mistake was he chose not to license it to Ford or General Motors. He decided he was going to make it himself. He decided to build his own factory. And so that's what he did. He took out a mortgage on his house, and he rented some big warehouse space, and he started building a factory and getting the equipment necessary and hiring the people. And he took another mortgage, and it took all of his money, and it took years. And 1962, 1963, 1964, he's still not finished. He still hasn't got to market. He comes out of this factory one day, it's raining in Detroit, and he turns the corner, and the new 1965 Mustangs are turning the corner to be unveiled to the world. And he sees in the rain that their windshield wipers are pausing. And he realizes that his idea has been stolen, and he's ruined, and he goes crazy, and the movie then talks about his descent into madness and all that. But that is a tragedy, and the tragedy is that it's too hard. It was too hard for inventors to become entrepreneurs. It was too hard to get to market. You had to give up control. You had to relinquish your dream because the cost of creating a factory was too high and took too long, and the barrier to entry to making physical goods was raised to the point where regular people couldn't do it. So that's changing. This is today a hacker space. This is a tech shop down in San Mateo, and these hacker spaces are growing up all around the world. What you're seeing here is the roots of a new entrepreneurial culture. I may or may not have a laser here. I do have a laser, but it doesn't show. The guy in the front is making communication modules for the smart grid. These are regular people, just entrepreneurs, inventors. The regular people, what they have is extraordinary tools. When you join a hackerspace, it's like joining a gym. But rather than getting access to the treadmill or to the weights, you're getting access to the 3D printers and the CNC machines and the laser cutters and the plasma cutters and the water cutters and the electronics equipment and the software and the training and the tools necessary to make almost anything. So this is a way, and these are showing up, it's like $100 a month, which is, maybe seem like a lot, but it's kind of like the price of a gym. And it's full of people with ideas, turning them into prototypes. The guy behind him, next to the one gentleman standing up, is creating a synthetic diamond device that takes a vapor deposition and turns them into diamonds. In the back, they're creating a lunar lander. Some of these ideas are crazy. Some of them are going to be the next sort of multi-million industries, and they're all being done by teams of one or two, using shared facilities, making prototypes. And when they get these prototypes and they work, they can then tap into global manufacturing and turn them into product lines and actual businesses. It's not an industrial revolution if it doesn't affect cars. And this is the world's first open source car. It's a Baja racer. Called the Rally Fighter, made by a company called Local Motors. And it's very interesting to think about the concept of of open source cars. As I say, industrial revolutions, if they're a real revolution, they need to scale. They need to be big. They need to employ lots of people and move the needle. And what you're seeing with a car is a reflection of a structural problem in the traditional car industry, which is that you had to be big to make one. The regulatory barriers are high, the manufacturing barriers are high. We've always had a small car business, and it's called the kit car business. And this is a way where you can weld together these steel frames or buy these steel frames, use off-the-shelf parts, and these fiberglass bodies, and you can create and you can make your own car. But it's always been a very small business. And the reason is that the designs of these cars are copies of famous cars, like MGs and Porsches and things like that. What happens often is that these car companies get sued. There's an intellectual property rights problem, which is that they have to pay licensing fees, or they get trademark infringement lawsuits or copyright infringement lawsuits, and they're constantly living with the legal threat that their derivative designs will create a problem, that there'll be some sort of legal threat. So the problem is not the car, the problem is the design of the car. So what this company, Local Motors, decided to do was to open source the design of the car. They created a community, and they challenged the community to take this airplane, the P-51 Mustang, which is a kind of a beautiful World War II fighter, and design a car that invoked the spirit, the aesthetics of that airplane. So they didn't base it on another car, they based it on another machine that was beautiful. And they said to the community, design a car that feels like it has that power and beauty of the airplane, but is a practical car. So what happens is the community very quickly did it, and they had competitions and contests. Now, it's interesting to ask, who are the people who participate in an open source car design contest? And the answer is they are a mix of professionals and amateurs. Every year, the #1 university for automotive design, which is called the Art Center in Pasadena. Every year, they graduate 120 engineers or designers who are focused on automotive engineering, automotive design. Of those 120, about 20 of them get jobs in the car industry. The other 100 go do something else. They design toothpaste tubes, something like that. What you have there is 100 people who've had to give up their dream. The dream was to design cars, and today they're designing toothpaste tubes. By day, they have a job, and they do a good job, and they have a good salary. But by night, they still love cars. This community was an opportunity for them to participate in their dream, for them to actually design a car. It's not their job, it's their hobby. It's not their vocation, it's their avocation. But they're world-class skills. They're happy to give the effort. In some sense, it allows them to tap into their passions, much as Sheni described earlier, the power of tapping into what people care most about, their passions, their interests, their loves, often is more important than money. And so this community formed around the notion of doing what people love, designing a car that was better and funner and more appropriate, and more to the point, being part of something, participating in a project that they were excited about. And so, one guy came up with a winning design, and then other teams focused on the rearview mirrors and the suspension system and the wheel wells, and everybody had a role to play. And in the end, this car just went into manufacturing 2 weeks ago. And they have a center in Arizona where you can build the car. Now, there's one other thing about this which is worth noting. The way it works right now is that you build the car. So you don't need to know anything about a car. What you do is you arrive in Arizona, in Phoenix, Arizona, and you're issued a flight suit, kind of a really cool kind of jumpsuit, and a toolbox. And there's a build center. And there's a mechanic who sits in the middle, and then 5 build stations around. And he will show you what to do, how to turn this, take this part, turn this bolt, and by night, you sleep at a dorm with the other participants, and it takes 2 weekends. And after the second weekend, you drive the car off the lot, back home. It's street legal. Now, the great virtue of this method is that because we have blurred the line between producer and consumer, it doesn't have the same regulatory barrier. So it doesn't have to be crash tested. Doesn't need to have airbags. Doesn't need the same kind of liability or guarantees of performance. Now you may say, I don't want a car that hasn't been crash tested, and that's fine. This car's not for you. But some people say, I'm fine with that. This is an off-road. It's an off-road racer. Maybe crash testing is not so essential, but because you have participated in the creation of this car, you're not a passive consumer. You're an active consumer. And when something goes wrong, you're not going to take it into the garage. You're not going to call up the manufacturer and ask for it to be recalled. They gave you that toolbox. You took the toolbox home. You built this car, you can fix this car. Or you know the community of other people who built the car, and they can help you fix the car. And so now you have this sort of shared responsibility, this shared participation in the product. And as a result, it can get to market faster and cheaper. It doesn't have to go through the same regulatory process that a traditional car would. So in a weird way, the open source car has advantages that the closed source traditional car doesn't. It doesn't cost as much to get the car into the market. It doesn't take as long. The little guys, the amateurs, can move faster and cheaper than the pros. And this is a very powerful model that's only possible because we're leveraging the web as a collaboration environment. This is that's the sort of the extreme end. Here's the sort of the other end. For last Christmas, my children. I have 5 children, but 2 boys, and my boys are really into Lego, but they're getting a little older. One's 12 and one's 9, and as boys who are into Lego get older, they start to also get into war. And battles and guns and things like that. It happens. I'm not proud of this, but it's one of those things. Now, Lego as a company has a rule against 20th century weapons. You can get Lego knights with swords, and you can get Lego spacemen with lasers, but you cannot get World War II Lego. Now, my boys are really into World War II, and what they wanted was to do World War II battle scenes with Lego. What they wanted was like sniper rifles and AK-47s and hand grenades. And Lego doesn't make that. So they said, well, Dad, what we want for Christmas is brick arms. I'm like, what's brick arms? And they showed me the site. And what brick arms is this guy here. Let's see if I can bring this up. This guy here. His name's Will Chapman. Will Chapman is a dad. And he also had boys, and his boys wanted Lego weapons. But rather than sort of say, sorry, Lego doesn't make Lego weapons, he did what now anybody can do, which is to say, he said, well, what kind of weapons would you want? And then they drew it out on the screen, using some free CAD software. And they drew out a sniper rifle, and the boys said, that would be awesome. And then he also had something that maybe someday soon most of us or many of us will have, which is that he had not a 3D printer, but a CNC machine, which is a way to kind of take the image on screen and then etch it out in metal. And what he etched out was a mold. And then he had one other thing, which you can get, which is a hand-pressed injection molding machine. And you take some Lego